Okay. All right, everyone. Good afternoon. Good to see everyone. So I want to do a few things today. Oh, I see a chat here. Okay, hello. I got a few wrongs, so I want to get some more practice on those. Yeah, we will actually continue doing some. We won't be doing too many word problems. We're actually going to start the next chapter, which will be solving the system of equations by using something called a matrix, which you'll see is actually very similar. The ideas are similar to what we've learned before, but we'll learn some interesting things about matrices. But yeah, Archer, which ones were you curious to have a little more practice on? Okay, maybe when I get the test back, you can look it over, and then we can talk about it if you have some questions remaining. And okay, so let's get started. I'll just share screen here. Okay. And I do actually, I'm going to do a little bit of matrices today. Just going to start it and talk a little bit about it. And then I want to do the extra credit problem. I want to hear your guys' thoughts about the extra credit problem from the test, as well as, if we have time, maybe do something, go through an idea that I mentioned a while ago. But we'll see how far we get. Okay, so let's see here. So this is called, oh, sorry, let me share my screen. Okay, so this is using something called matrices. Matrices and something I'll call a Gaussian elimination to solve linear systems of equations. Oh, yes. So Shay, exactly kind of what Archer said. I did make the overall grade accessible to everybody in the class. So yeah, just maybe go to one of the tabs, I think, that says your work, and it'll have your overall grade there. And I haven't turned in I haven't returned the test yet. Okay. So we saw earlier an idea that if we have a system of a two by two system, 2 by 2 linear system, and remember the term here, linear. Linear just means that you're just working with like a simple x, y, and z, and just numbers in front. There's no like x squared, there's no y squared, there's no exponents or anything like that. Just simple x, y, z is being added together, equaling to some number. So that's what we mean by linear. And kind of the reason we have that is that the shapes that these objects make are like flat. So we saw in one dimension, you get lines when you have a linear equation. In two dimensions, and when you have x and y, you get a straight line. When you have 3 variables, you get a flat plane when you write a linear equation. Okay, so here's a system. So x plus y is equal to, let's say 5, and let's say 2x minus 3y is equal to negative 5. Okay. And we learned how to solve this using elimination, using substitution. And so now we're going to learn a third way, which is really going to be actually similar to elimination, but this is a nice way to introduce the idea of matrices, which I think is actually a really important topic to learn nowadays, especially if you are kind of interested in computer science or data science or any kind of lots of types of engineering or AI. It's really nice to learn about matrices. So that'll be the focus for the next 2-3 weeks. We'll learn about these ideas. And you'll see it's actually really simple. So what we did was, when we set up by elimination, what we did was we always match up the x's. We match up the variables. So we have an x column, right? And then we have a y column. And when you're doing elimination, you try to keep everything consistent so that, and then we have a constant column. We try to keep everything consistent because, like, you wouldn't want to, it's nice to line it up so that you can subtract things right underneath each other. So for example, we'd multiply everything by, first maybe you would multiply this by positive 3, let's say. So you'd get 3x plus 3y equals 15. And then you can do elimination, and then you get 5x plus 0y is equal to 10. And then you find that x is equal to 2. And then you can solve backwards. So this is pretty straightforward. One person is in the waiting room. Okay, so how are we going to do this with matrices? And what is a matrix? So a matrix is essentially, in the beginning, you can just think of it as a way to store the coefficients of this linear 2 by 2 system. And it's just a shorthand so that we don't need to keep writing all these variables. Do you guys see that, like, if I agree on the convention that this is always going to be the x column, I can save myself a lot of time if I just don't rewrite all the x's. And I can also save myself a lot of time if I don't rewrite all the y's here. And then this will just be a number. So we write the following. Expression. So if you have a system, what you do is you put the coefficients in a square, of each equation in a row. So you write 1, because it's 1x and 1y. You write 1, 1, and then you put a little bar here. And this is what we call the augmented part. This is the augmented, and I'll talk a little bit about why we call it the augmented or the target later on. But this is just kind of like what you want to, the equations, what constant you want the equations to result in. So first you write everything in standard form, you put it in alphabetical order, and then you write out the coefficients and the number that you want those coefficients with x's and y's to reach to. And then over here, what do you guys think I should fill it in? What would the second row be? Anyone want to take a stab at it? Nice. It would just be 2 minus 3. And then what about the number past the bar? -5. Perfect. That's it. Okay. And this represents all of the information exactly, and no more, no less. This captures all of the information that we just had. It just looks a little bit different. It just doesn't have the x's and y's, but it's a nice way of writing it all down. And this is what we can do with these kind of, we're going to now think about, like, what are the operations that we can do on this matrix with an extra column, with an augmented, so this is called an augmented matrix, because it's a matrix is just a rectangle of numbers, and then if you want to add a column that represents the target, you just put a little bar and you kind of extend your rectangle of numbers a little bit. So what are the things that we can do to a matrix and still really keep it representing the same thing? And if you keep in mind that the matrix represents, each row of a matrix represents an equation, then there's a few things you're allowed to do. So these are called the elementary things you're allowed to do. And I'm going to about to write some of the operations, and just kind of think about what each of them represents and why you're allowed to do it. So these are the elementary operations. Well, let me see. Before we, I'll mention what they are. Elementary operations on rows, or rather, in the original setup, it'd be equations. What can you do on actual equations? So, Lily, nice. You can multiply. So, like, for example, if you have x plus y equals 5, if you multiply that entire row by 3 and just swap that out and make it a new row, 3, 3, 15, it looks different. But we saw that when you have an equation and you multiply both sides of it by something, you don't actually change the meaning or the points that satisfy that equation. You may change what the equation looks like, but you don't change the actual equation. So one thing you're allowed to do is you can multiply an entire row. So that's one thing we're allowed to do. And replace it. Oh, by you don't want to multiply by a non-zero, by a number that's not equal to 0. Because if you multiply it by 0, that does mess it up, because then you get 0 equals 0, and that's not good. Can anyone tell me what's something else I can do with rows that wouldn't change the solution to the system? What's something else that I can, and maybe just think about what could you do with the way that you write your equations? Is there another matrix I could have written that would have the same exact solution for x and y? Yeah, if you can do an overall factor. Yeah, so yeah, one thing let's just is you can switch. So one thing you're allowed to do is you're allowed to swap any equations. Do you guys agree that if I were to just rewrite, like put this one second and then this one first, would that be the same system? How many of you guys think that would be the same system? Nice. Oh, somebody said no. Nice. Okay, good. Uh, yeah, if you switch the rows, or switch, you can think of the equations. If you switch two equations, it's exactly the same system. Just, you can order the system of equations any way you want. So another thing you're allowed to do is you can swap rows. So you're allowed to swap rows. Okay, and the third step is actually something, it's the key to elimination. What is the key step with elimination? What are you actually doing with the two equations? Yeah, you could, nice, Gabby. You can combine them, and then you can combine two equations and have them cancel something out. But in general, one thing you should be able to do is, if you have two equations of lines, then you can actually add them together and replace whatever you get, replace the new thing with, replace the old one with whatever you get. So you can combine rows by either adding or subtracting, because that's kind of the same thing. So you can combine rows and replace. Okay, so let me kind of walk you through the steps here that you would take to recreate what we just did. So the first thing that we did is we multiplied the first row times 3. So what I would write here is, let me just copy and paste it. And the key to doing this is being very careful with how you write your details and descriptions. Okay. So the first thing we do is we multiply the first row by 3. So I'm just going to write 3 times R1, and I'm going to rewrite the entire system. So this will be 3, 3, 15, 2, minus 3, and this will be negative 5. So this way I know this R1 over here corresponds to R1, the first row in the previous problem, in the previous step. Okay, now the next step would be to add the first row of the new thing to the second row and swap it out with the second row. So let's try that. This would be 3, 3, then 15. And then over here, it would be 5, 0, and 10. So this is going to be R1. I write underneath, in front of the row, what it got replaced with. And it's a little bit, the notation here, when you write these steps, this R1 and R2, it comes from the previous, the R1 and R2 from just before. Right, maybe I'll write it like that. Maybe a better color is orange. Okay, so we're just kind of doing this step by step. Okay, and then what can we do next? How do we try to solve for y here? Or sorry, solve for x. Any ideas? Any ideas what we can do? What should we do to the second row to allow us to solve for x, because I have 5x plus 0y equals 10. So what's a simple thing? Yeah, I would just divide by 2. Oh, sorry, divide by 5. Sorry. So, and I'm being very careful with all the details here and writing everything out. And when you do this later, you can kind of jump right away to some steps. But I would write here 3, 3, 15, and then 1, 0, 2. And over here, I would write record where this came from. This came from the previous row 2, and it got cut down by dividing by 5. So it's this row here. Okay, now this is kind of where it gets a little bit interesting. How can I, how do I go about solving for, what is it? Oh, solving for y? What can I do next to get y? And it seems like we're doing a lot of work, because usually you just plug back in and get y. But we'll see in a second kind of we're doing this to get to make an observation about these systems. Anyone have any ideas what I can do? How can I try to get y by itself? What do you guys think? Yeah, let's divide row 1. That's a good idea. So if I divide row 1, let me actually do it. Yeah, I could have done it one step there, but I'll write another step here. So if I divide row 1, I can get 1, 1, 5, and then 1, 0, 2. And if you notice, this is going to be row 1 divided by 5. If you notice, this is really, whenever you have a 1 and the other one is a 0, you basically get one of your answers. So how can I turn this into a 0, 1? Oh, thank you. I got to divide that by, wait, no. Oh, I think that's right. I think that's good. Ah, I see, I see. Thank you. Yes, that I do have to divide that by 3. I see. I divide everything by 3, and that's 1, 1, 5. Okay. How can I turn the first row to make it have a 0, 1 instead of a 1, 1? Nice. I can subtract, right? I can subtract the first row and take away the second row. So when I do that, I get, so this is going to be R1 minus R2. So this would be 0, so rather 1, 3. And this is 1, 0, 2. Okay. Thumbs up if you followed all the steps that we did, and it kind of makes sense. We're just kind of doing regular elimination, but we're not writing down the x's and y's, and we're just keeping track of what we're doing to each equation, and we're replacing, every time we kind of combine rows, we replace one of the rows that we worked with. So let's look at this last thing, and this is kind of what I mentioned. If we go back to equations, what does this tell us about y? Lily asked a good question. What is the purpose of this? Because it seems like we're doing a lot of extra steps. You're right. So there's yes, this seems more complicated than elimination. Yes. So one thing that it will allow us to do is first, it will allow us to um, come up with a algorithm. So something that you don't need to think about, but you can just do it no matter what, for solving any n by n system. And then learning about these matrices, we'll see another interpretation. Rather than thinking about two lines meeting at a point, we'll see another way to do it. And there's another reason for this, for doing it this way. For 2 by 2, I would say doing matrix, this is called Gaussian elimination. For a 2 by 2 system, you don't need to do this. For a 2 by 2, it's like, it's pretty simple to just do regular elimination because you only have two equations. You just eliminate one variable, solve for the other, back solve. But once you start having like 3 by 3 or 4 by 4, if you remember, it can get pretty complicated and you start writing lots of things down. So the one benefit of using these matrices is it allows you to just keep all of your ideas or all of your equations organized, and it allows you to do elimination in a very systematic way. But I agree, for 2 by 2, it's not. This is like overkill. And I would say the main advantage of this method that we'll see in a second is to allow us to do something, solve it in a very systematic approach. Okay, so this equation implies, the first one implies y equals 3, and the second one is x equals 2. Okay, good. And our example, we did it, I just followed the steps that we did from elimination, but I should have told you kind of what the role of Gaussian elimination is and how it's a little bit different, but almost the same thing. So you see kind of this final configuration that we got here? It turns out that in Gaussian elimination, we try to get something very similar at the end, because if you get a bunch of ones and zeros, you can figure out what your final answer is because you just read it off. You can know x equals something, y equals something, and so forth. So the goal when you're doing Gaussian elimination is actually to end up at something called the identity matrix, which I'm going to write here. It's going to look like this: 1, 0, 0, 1, and then your answers A and B. So this is the actual goal that we want to get to. We want to get to something with the identity. This part is called the identity matrix. And we're going to kind of see another reason it's called the identity matrix. Very good. Archer asked a really important question. How do you know which one is the y, which one is the x? So the convention is that it's in alphabetical order, that this first column, the first column is always the x column, and this second column is always the y column. So it's just in alphabetical order. So in other words, if you can do the elementary operations of swapping rows and multiplying them and stuff like that, and you can get it down to this identity matrix, what that would mean, if you rewrite it and go back to equation form, this would be 1x plus 0y is equal to A, and 0x plus 1y is equal to B, which is really just the fancy way of saying x is equal to A and y is equal to B. So what we did is really close to what Gaussian elimination is, but we kind of the last step we would do to get it to look like the identity matrix. Can anyone say what the last step would be if we wanted to make it look like the identity? If we want to make it look like this, what operation could we do to our final step? There's one thing we can do at the very end if we wanted to make it look like this. Yeah, nice. We can just swap the rows. Okay, good. So now that we went through one example, I'm going to show you how Gaussian elimination works. And the strategy is going to use these elementary operations, and our goal is to get the answer. What is x, y, and maybe z, or what are the answers? Okay, so let's do one more example. And I'll show you, kind of go through the idea with it. So let me think here. So let's do this equation. So x plus 2y, let's do 3x minus 3x minus y, and I'm going to do here 7, and this one is 0. Okay. All right. So first, here's this 2x2 system. The first step is, can you please write this as a augmented system? And let me know when you got it. And now what we're going to do is we're going to do the systematic approach of Gaussian elimination. This is something you could technically program a computer to do step by step, because they would always kind of nice, excellent. So the first row I'm seeing people write, very good, would be 1, 2, and then the big bar, 7. And what about the second row? Nice, 3 minus 1, and then still past that line is 0. Okay. So remember our goal. Our goal is to get it to look like this. Our goal is to turn our system into an identity matrix, and then after the bar, these will be our target will have turned into our answers for x and y. So in order to follow that, in order to reach that goal, we use something called the pivot. The idea is we try to kind of make, the thing about the identity matrix is it always has ones along the diagonal. So it's always going to have, we want it to have ones along the diagonal and zeros that are off the diagonal. This is 0, this is 0. So we want our matrix to get into that shape. So the first thing we do is we look in the top left corner and we see if this is we try to make this number 1. In this case, it already is a 1, but this number is called our first pivot. And what you can use this pivot for is you can use it to eliminate any number that's directly beneath it and swap it out. So I can use that 1, and if there were more rows underneath it, if it was a 3x3 system, for example, I could use the pivot to eliminate everything underneath it, as long as I have a 1. So for example, how can I use that 1 to turn the 3 into a 0? What do I need to do? Nice. I multiplied the first row by a -3, and I added to row 2. So let me write it down. So I want to keep that 1 because remember, our final answer is going to have a 1 there. So that 1 is good. So I have 1, 2, 7 bar. But now I'm going to do this in my head. I'm going to do -3 row 1 plus row 2. So -3 of this plus so -3 of these plus this is going to be 0. Can anyone tell me what I would have in the next entry? Nice, very good. So you do minus 3 times 2. So minus 3 times 2 is -6, and then minus 1 is going to be -7. So this would be -7. And then how about in the third entry over here? What would the last one be? -21. Good, because it becomes -3 times 7 is going to be -21, and add it to 0, you just get -21. Great. Okay, and now we're looking kind of like what we need. We have a 0 here, which is good, but we want to turn this number into a 1, because it's got to be 1 0 1 0, like, or it's got to be 1 0 0 1. So how do we turn this into a 1? Ariana mentioned that this part is a lot like elimination, but just maybe a little more confusing. We'll get a little more practice like this, but this is a very systematic elimination where we start with a matrix and we try to manipulate it so that our end goal is to get that a matrix that literally just we can read off the answer, and that matrix that we want is going to be a matrix with all ones down the main diagonal, so from the top left to the bottom right, and zeros elsewhere. So yes, you're right that this is a little bit more confusing than just regular old elimination that we did, but you'll see that it allows you to be very systematic for larger systems. So now we're just doing 2 by 2s because we can kind of see how the mechanics work out. Yes, Gabby, what should you divide by? Nice, divide by -7. So that's a totally okay operation. So you have 1, 2, 7, and then 0, 1, 3. And this is going to be this is going to be R2 from the previous step divided by -7. So I kind of know what you did there. All right, now we're almost done. Basically, this is the step where we're actually going to, it's equivalent to back solving now. But we're going to do it a little bit differently, right? Because we want to make it look like the identity matrix. But you can essentially tell yourself, once you have your final row and it looks like 0, 1, that means that you've solved for y. So what can we do? We have 0, we have 1, 0, 1, and we have this, now that we've used this pivot to clear out everybody down here, we have a new pivot, and we can use this pivot, this 1, to clear out everybody above. And we don't need to worry about messing up the previous pivot because anybody to the left is a 0. This guy is a 0, so it's not going to mess up anything we do to this. Anything we try to do to eliminate this 2 now won't mess up the original 1 because this is gone. So what can I replace the first row with? What should I do? R1, nice. R1 minus 2R2. So multiply the second row by -2 and basically add it to R1. So I'm going to write it here. This is going to be 0. I'm going to keep this row, 0, 1, 3. And then I'm going to do R1 minus 2R2. So this will be just 1, because 1 minus 2 times 0 is 1. Then it's going to be 2 minus, so it'll be 2 minus 2 times this guy, which is going to be 0. And what is the last part here? So what is 7 minus 2 times 3? That'll just be 1. Okay, that's it. We finished. Our matrix is now an identity matrix, and we can just read off the answer. Based on this identity matrix, what are the answers? What is x equal to? And what is y equal to? x equals 1 and y equals 3. Okay. Just a show of hands, have any of you ever messed around a little bit with the Rubik's Cube? Nice. Okay, a few of you have. Have any of you how far have you been able to solve it? Like maybe solved it all the way, or you guys like? There's a really good movie, by the way, on Netflix with about a Rubik's Cube competition. Not far. Have any of you ever been able to like solve one layer, one side? Okay, cool. So people get to one side. Some people didn't make any progress. It's pretty hard. Um, two sides, maybe two rows at best. Very good. It actually gets like after the first row, the first layer, starts to get really hard. And you just kind of have to learn. If you want to learn, it's hard to figure it out, but you could learn. You could look online and learn the method for it. But the reason I bring it up is it's some of the ideas is like as you're making the Rubik's Cube, and let's say you kind of do it layer by layer, what you start to do towards the end is the moves get more complicated because you want to change stuff in the bottom layer or the middle layer, but the key is you don't want to mess up the things that you already did. So you always want to do things that kind of preserve what you already did. And that kind of reminds me of the matrices, because the nice thing with the matrix with these pivots, so our pivots are going to be these ones on the diagonal. These are generally the pivots that you use. The nice thing about this format is that because it's like you're solving kind of moving down, and then later you solve kind of going back up. And as you try to use the pivot, like the one in the second row, to eliminate that 2, because you had a 0 right next to it, you don't have to worry about messing up the other pivot. So maybe let's try a 3x3 so you guys will see this in action. Okay. Are there any questions about this example? You know what? Let's go. Let's actually try another. I'm going to give you guys a 2x2 to try on your own, to just make sure you can do these steps, and then we'll do a 3x3 together. Okay. So let me give you guys one to try on your own. And then I'll ask everyone maybe in a few, like maybe when you're done, please just, because it's quite a bit of writing, just post it, turn on your camera and just show your work on the camera, okay? So I just want to make sure that everyone's doing that. Thumbs up if you're okay to do that. Cool. And I'll take a look. Okay, great. So let's do another one. This one will be, and remember what we want to do. We always want to start making these diagonals, making them 1. As by making the first one, we start with this first one, trying to make it a 1, and then we use it to eliminate the guy underneath it. Then we try to make this one a 1, and then we use that to eliminate the guy just above it. Yeah, yeah. Just turn on the cam. If your camera's working, turn it on, and then this way I can see your steps. Because this, it's not just we know how to get the final answer, but I just want to make sure you can do the elimination. Okay, 2x plus, oops. Try this one. 2x plus 4y equals 10. And then x, let me see here. X minus 2y equals, let's see, equals 1. Okay, I'll give you guys a few minutes. Let me know when you're done, and we can go over it. Oh, well, hang on, hang on. All right, guys. So I'm seeing a few students have questions. So let me see. Can you, Allison? Oh, sorry, Lily. Can you show? Can I see your work? Let me see here. I'm gonna. Is it gonna be? Yeah. So the first pivot that the first pivot that you want to use is always going to be in the top left. Okay, good. So you got the first part of the, okay, good. Good job if you got the augmented. So let me write that. I think a lot of people kind of got that down. So let me write the first part down. So the augmented thing will turn into 2, 4, 10, 1, minus 2, 1. Okay. So, okay, that's right. Gabby mentioned, so we always, when we do our pivots, the way we go with our pivots is we always want to pick we always want to we always want to turn it into identity. And so we try to make the pivots go from, this is our first pivot, and then later when we clear everything out, this is our second pivot. So Gabby, if you want to turn, there's two approaches. There's actually not just one way you can do this. You could, does anyone see a way to turn this number into a 1? What's the first thing you could do if you wanted to make this into a 1? There's actually two things that you can do. You can divide by 2. So that's definitely one thing you can do. You can divide this whole thing by 2. There is something that makes your life a little bit easier that you are allowed to do. Does anyone see anything else that you can do? Instead of dividing by 2, how can I keep the same system? I can swap. Exactly. So you are allowed to swap. But let's just divide by 2 because it turns out to be nice as well. So, so if I divide by 2, I'm just going to get 1, 2, 5, and then 1, -2, 1. All right. How many of you, and please message me, give me a yes if you got to this step, and a no if you didn't quite get to this step, but now you're okay with it. Okay, so now that you saw the first step, are you okay with it? Those of you who said no. Okay, cool. So it looks like most people are okay with it. Okay, what can we do for the second step? We're going to use the pivot, which is this this guy. Let's use this pivot to eliminate the guy underneath it. So what can you do to the second row? And this is going to be kind of like the elimination step. Nice. Nice. You multiply -2R2. Oh, -2R2. Oh, okay, I see. Ariana, yes, very good. So you do want to try one nice thing that we try to do is we try to always make our pivots, we try to turn them into 1. Because when you have a 1, it's easy to cancel stuff with a 1. It makes it very convenient. So your approach there wasn't terrible. It would also work, but it's nice to just keep it, to turn things into 1s if you can. Okay, please message me if you think you got the second row, or if you're stuck. And I'm happy to take a look at your work too. I can look over your work. Okay, Allison, you want to share your work on the camera? Okay, hang on, I can see here.
Oh, okay, so can you see it?
Yeah, I see it.
Okay, well, I don't understand how to like do these because you have the pivot, but what did you divide by 2? I don't think you can see it.
Yeah, okay, so you did the pivot right, so you divided by 2, and you got 1, 2, 5, good, okay.
I've kind of just been like copying your work, so I just don't understand how to do these.
Yeah. So so the thing is the last column, it kind of just like, we're just going to be, you never try to do things you never try to worry about like controlling what's in the last column. It just kind of follows all the steps that you do with the first 2 rows, with the first 2 columns to try to get that pattern 1, 0, 0, 1.
Okay, wait, so we're not like doing it by row, we're kind of just doing it by like one individual number? Or is it like, oh, okay.
I think so. Yeah, I would say like we're trying to turn the part. What we're really trying to focus on is the part before the bar, right? These are like our x's and y's.
Okay.
And what we're trying to do there is to turn it into 1, 0, 0, 1, because, and then as we're doing that, it's kind of like in the Rubik's Cube. If you try to just focus on like making the first layer of the Rubik's Cube look nice, you're not really paying attention to the other layers, and who knows what's going to happen. That's kind of like what happens here. These numbers just keep getting changed around, and at the end, when we're done, it's going to be our answer.
Okay, that makes more sense.
So now, what can you do? So we got our 1 in the top left. What could we do to that using that 1? How can we use that 1 to get rid of the 1 to turn the thing underneath it into a 0? How do we combine the 2 rows to turn this 1 into a 0?
Do you pivot?
Yeah, you want to use the first row. You want to use that one I colored in purple, and maybe take it and subtract it from the R2. Right? That would kill off the ones. So I'm going to write over here 1, 2, 5, and over here I'm going to write R2 minus R1. So just take everything in the second row and subtract the first row. Do you agree that this is going to be a 0? Because it's just 1 minus 1. How about in the second, how about this guy? What's that going to turn into? I want to take the second row and subtract the first row. That would be minus 4. And then how about the last number? Okay, nice. I see a lot of people getting minus 4. Good. Any questions on how I got minus 4 there? Thumbs up if you're comfortable with why I just wrote minus 4. Okay, don't understand minus 4. Okay, so R2 minus R1 really just means R2 is in the previous, from the previous thing is R2 is this one, 1 minus 2, 1, and R1 minus R1, or let's just do R1, is going to be 1, 2, 5. So if I subtract them, if I subtract the rows, it's like subtracting the equations. We're just combining equations. This is like x, y equals, and this is like x plus y equals. Same exact thing. You get 0x, you get minus 4y, and then you get minus 4. So the R2 minus R1 is going to be 0 minus 4 minus 4. And if you get rid of all the x's and y's, let me rewrite it. So the x's and y's just to show you that it's the same thing as kind of what we were doing before. But we don't really need to write it because x's and y information is stored in the position. So this is going to be 1, negative 2, 1. And you take away the row 1, 2, 5. So subtract this, you get 0, negative 4, negative 4. And that's why I wrote, that's how I got this part. That's what I'm doing when I'm combining rows. Any questions on this? How I got that last part? And when you're doing this, you will have to do a little bit of like kind of mental math, like, oh, why did we do that? We did that to get a 0 right here. I wanted the 1 to cancel. I wanted to do R2 minus R1. So that's the only reason I do it. Okay, now that I have minus 4 and minus 4 here, remember I want to get a 1 over here. So what can I do to R2 to get a 1 there? I divide everything by minus 4. Is everyone okay with that? Please hit yes if you're okay with how we got 0, negative 4, 4. And then we can now divide everything by negative 4. Sorry, divide the second row by negative 4. And there'll be one more step at the end. So we have 1, 2, 5. And now we have 0, 1. And negative 4 by negative 4 is also 1. So we have this one. We have R2 divided by negative 4. Okay. Last step is to use the final pivot, and we're actually going to clear, there's nobody below it, but we're going to use the final pivot, which is this guy. This is the final pivot. We're going to use it to clear everybody above and below, but there's nobody below, so we're just going to use it to clear the guy above. What equation can I do to the guy above, or how can I combine the two rows to eliminate the 2? Nice. So write down, please send me what you think I should replace the first row with. And you can write like R1, R2, or R1 plus R2, or R1 plus 2R2. Excellent. I'm seeing a few students write it. Aiden, not just a regular R2. Excellent. I'm seeing, okay, great. Awesome. So it's going to be very close. It's going to be R1 minus 2 R2. So I'm going to keep R2 the same, 0, 1, 1. And now this is the part where I'm not going to write it down. I'm just going to kind of do this in my head. I know this entry 1 minus, I'm just doing the pattern. So it's going to be 1 minus 2 times 0. Well, that's just going to be 1. So I can write it in there. Then I look at the previous one. This was 2, right? So it'll be 2 minus 2 times 1. That's just going to be 0. That's by construction. And the last one is the most important, because you could kind of already know you don't need to do any math on this one, because you know it's not going to change because you can't affect the 1 with the 0. And you know that you're trying to turn this into 0, so that's by construction. But it's really the last one. So what do we do if we do 5 minus 2 times 1? What does that turn into? The last number would be 5 minus 2 times 1, which is just going to be 3. And thus, we can read off our answers. X equals 3, and y is equal to 1. Okay. It takes a little getting used to, but once you get the hang of it, you see that this is actually a really nice systematic way of doing these, and it's really good for larger systems. For 2x2, this is overkill, but for larger things, it's nice. How about we try one more example, because I know there's a lot of students that were a little bit lost on this one in the beginning. Do you feel, those of you who are a little bit lost, let me clear the responses. Those of you who are a little bit lost and weren't sure how to move forward on these, do you feel a little bit clearer after this last example? Okay, let's try one more, because I want you guys to kind of get the confidence of that you can do it yourself. And I like these. I like making the pivots. You know, you're always trying to turn. The goal is you start off with the upper left, turn that into a 1 somehow, and then use that to destroy all the numbers, turn all the numbers, all the rows underneath it into a 0. And then you go to the next step right underneath it, and you use that to turn everybody above and below into 0. And you can keep doing that systematically, and you'll get, at the end, you'll have a big matrix with all 1s, and then you can just read off your answers. So we're just doing with X and Y, but if you do X, Y, and Z, you would have a 3x3 system. So you'd have you know, a bigger matrix to work with. Let's try one more. So let's do this one. 3x. Let me just give you the system. So 3 minus 12 and 15. Let's see. 3 minus 12 and 2 and 4. So let's see. Let me just think for a second. And then the augmented part will be the augmented part will be 15 here and -2 here. Okay. All right, guys, please try this one, and then we'll call it a day. Oh yeah. So Gabby asked a really good question. Like, you see, kind of sometimes when you're doing row replacements by combining stuff, only do that kind of. You are allowed to do multiple operations at once. Just kind of be careful so that you don't get too confused. But definitely, Gabby asked, can you divide rows at the same time? For sure. You can divide, you know, if you want to divide the first row and then divide the second row by some number, you can totally do that. And even if you want to, like, when you do 3x3 systems, you'll be able to combine 2 rows at the same time. Like, you can combine the second row and the first row and swap it out. And you can also do it at the same time. You can do something with the third row. That helps when you're doing the stuff with the pivots. So you can definitely combine steps so that you don't need to rewrite all these things all the time. And let me know when you got it and I can take a look. I'd like to see your work also. Yeah, if you want to show your work, just turn on the camera and then I'll kind of zoom in on your camera and take a look at the picture. Okay, hang on. Okay, I'm just gonna look in a second. Okay, great. I'm looking now. Okay, so good. Awesome. So you divided them good. Hang on. Okay, good. Okay, I like the first step is good. The second step, you do excellent. Excellent. The first, nice. Okay, so far so good. I like the second step. Then you do 6 minus 6. You do R2 divided by 6. Good. You have 1, negative 1. Awesome. Okay, so you got Y. Okay, now let's go. Oh, hang on. Okay, so it's the step, the second to last step, or that one.
This one?
Yeah, that one right there. Yeah, so right there you did, I think you did something. Let me just take a look what you did. It looks like you, what did you do there? Oh, -4. Oh, okay. I think you had the right idea. -4. Oh, okay, gotcha. You see, you wrote -4. What you might have wanted to do there is you want to replace the first row. You want to keep the second row 0, 1, -1, but you want to replace the first row.
Okay.
You're really close there.
Okay. Did I get the first right, the Y right though?
You got the Y right. It's
So I just got X wrong?
You got the X wrong, yeah.
Okay.
Take that second row and use it to wipe out the first row.
Okay, perfect. Thank you.
Annette, let me take a look. Can I take a look at your work? And sorry, let me just post the share my screen here. Okay, I'm gonna take a look. Hang on, sorry. Okay, I see it good. Okay, that looks good. Excellent. Divide everything by 3. Divided that by 2. Hang on. 2, 4, -2. And then multiply. Oh, can you tell me what did you do to get in the third step? What did you do there?
The third 1, 2, 3. So I did the second row divided by 2. So that way, when it was the 2, 4, -2, I could get 0, 2. Oh shoot, my bad. That was supposed to be a 1.
Excellent. Good catch. Yeah, these are sometimes tough to grade because there's a lot of spots, just like regular elimination, where you can make a little mistake. Okay, I'm gonna write the steps here, but I'm glad that you guys were on the right track. So yeah, the first thing is you are allowed to do multiple things at once. So I'm going to write the first thing will be divide the first row by 3 and the second row by 2. So that would just be, that would give me a 1 here. That's good. And that would also, it's nice to you don't need to divide it, but it's a nice thing to do. It just makes it look a little bit simpler. It's always better if you ever see a common factor in a row, you can always just cancel it out. That's a nice thing to do. And this would be -4, and this one would be 5. All right. Now we want to use our pivot, this one, and eliminate right underneath it. Well, that would tell me to use R2 minus R1. And if you didn't cancel R2 earlier, you would just do R2 minus 2R1. And nice, I'm seeing a few of you got the right answer. Very good. Keep the first row because that's our pivot row right now, -4. Well, that's the that's the row that contains the pivot, so that's not going to change. And we're going to use this row and subtract it from the second row to eliminate the column right underneath the 1. So that'll be a 0, and then 2 minus -4 is actually going to be 6. And then -1 minus 5 is going to be -6. Okay. And now this is nice because our next pivot moving down diagonally is this 6, but we want to turn it into a 1, so we just divide everything by 6. So we have 1, -4, and 5, and then 0, 1, -1. Because I divide everything, I do R2 divided by 6. All right. Last step is now I'm going to use the second row because I have a new pivot, which is this one right here in the second row. I'm going to use that one to eliminate anything above it. So instead of R1, let's write R1 plus. So how can I use this one to eliminate the -4? What should I do? How many of these ones do I need to eliminate a -4? I need +4 of them. Exactly. So in this case, I'm doing R1 plus 4 R2. And that's really the power of turning your pivot into a 1, is this makes it really easy to tell what you need to use to eliminate. So this will be 1, 0. That's not going to change. And this is 0 by construction. -4 plus 4 is going to be 0. This will stay as 1. This is also going to be -1. And then what's the last number? It's going to be 5. It'll be 5. This is 5 plus 4 times -1. And that's just going to be +1. And that's our answer. X is equal to 1. Y is equal to -1. Okay. So that's it. That's Gaussian elimination. It's kind of a systematic way to use the elementary operations to turn your matrix, your augmented system, into something that looks like we call the identity matrix, which is ones along the diagonal going from the top left to the bottom right. And then we can just read off the answers in the final column. Okay. Are there any questions? I know it took a few examples, but do you feel a little bit better after seeing these? Is the steps a little clearer? Awesome, and it takes some practice. I'll post some homework. Some people still a little shaky. That's okay. I think by the end of this, you'll see it is kind of a tedious thing to do, but I think you'll find that the idea of it is quite nice. And the cool thing is it'll allow you can apply the same idea with the pivots. You can extend the same idea to solve like a 5 by 5 system. So if you have a really big system like 1, 2, 3, 4, 5, and then 6 here, and then, you know, a bunch of numbers. So this is like a really big system. You can do exactly the same idea. You turn this into a 1. In this case, it already is a 1. And you use that 1 to eliminate everybody underneath it. So that's kind of the big picture. So you eliminate everybody underneath it. So for example, I would write the next step I would do like I would keep that the same 1, 2, 3, 4, 5, and then whatever it is, 6. And then the next one I would write here, because there's a 2, I would turn this into a 0 by doing R2 minus 2R1, for example. And then this would be 1, this would be 1, 1, -2 minus a would be -10, and so forth. So you can do that. And then, so once all of these are, and then you do the same thing over here. So you turn this into a 0, 0, 0, and then you do the same thing moving on. You do the same step to the next pivot, and you turn, but this time you turn, you use that pivot to kill off everybody below and above. And then you keep going with the pattern. So you keep using these pivots, and then step by step at the very end, it's like you've completed the Rubik's Cube in a way, and you will have you'll be able to read out your 5 different answers. Instead of for a 5 by 5 system, you don't have X, Y, Z, you have X, Y, Z, W, V, or something like that. You'd have five unknown letters. All right, guys, that's all for today. And I will see you guys tomorrow. And if anyone has any questions, also I'm happy to stick around. If those of you who were a little bit confused, if you want to work through another example. But otherwise, I'll see you guys tomorrow.
Thank you.
Yes, definitely. I have all the recordings. I'm going to try to post them. I'll try to post some of them today. I just have been slacking on keeping track, and I have to download and upload them from Zoom and then to YouTube. So, but I will try to get on it. See you guys.
Mr. Minisky.
Yes, Colby.
So for my test, it said it was missing, but I filled out the Google form and turned in the test on Thursday, but it said it was missing for some reason, so I resubmitted that.
Okay.
I have no idea why that
No
it
problem.
was missing, so I just wanted to make that clear.
Okay, got it. Thank you.
I'm so sorry about that.
No problem. Sometimes I understand it's doesn't go through properly.
Okay, thank you. See you tomorrow.
Definitely. Okay, see you, Colby. Bye.